How SyncE or Synchronous Ethernet works, a presentation by Calnix Solutions. This video will explain how Synchronous Ethernet, a new technology that enables timing and synchronization to be transported across a packet network, works. The idea here is to enable synchronization or a clock in a network to be transported from a core site, which is usually controlled in the case of synchronization networks by a PRC or a primary reference clock. We need to get the synchronization of this clock across a network to multiple sites. Reason being, we need these sites to be frequency locked or synchronized, for example in the case of a mobile network, to enable calls to be made across the radio interface, and also to enable calls to be handed over between one cell and the next cell. So in order to synchronize this network, we need to transfer synchronization from a single source across a network. Traditionally, this was done with the TDM or PDH SDH SONET networks by using PDH SDH SONET equipment. With Ethernet, we need a similar method to be able to lock and transport synchronization across the packet network, and this is provided by SyncE or Synchronous Ethernet. Synchronous Ethernet or SyncE is the ability for a piece of equipment to lock its oscillators and synchronizers to a reference source and then to transport that synchronization onwards, as shown here by the green circles in the diagram. If all of these equipments are all locked together and synced to a single source, we achieve what we need to. So let's look at a bit more detail how SyncE will work. SyncE fundamentally, just like TDM, uses the line rate or the line coding of the Ethernet interface to transfer timing. Every optical or electrical signal will have a clock edge, and this clock edge is what is used to synchronize or to extract timing. It does not use the packet layer in Ethernet. It's a purely physical technology. And there are two fundamental differences between traditional or legacy Ethernet and synchronous Ethernet. And the two differences are explained first of all at the bottom of this diagram. Legacy Ethernet physical devices, or PHY, at the interfaces have standalone oscillators. And this is a problem because remember, what we're trying to do is we're trying to lock the incoming signal to the outgoing signal, and there is no such path in this device. A synchronous Ethernet device does have this path, as shown by the red arrow here. The local oscillator is locked to the incoming received signal, and that is then used to clock the transmit signal. And by having this architecture, you can then lock a bank of network equipment across the network, and therefore synchronize the whole network to a single source. The other big difference with synchronous Ethernet is that it does use a higher quality local oscillator, 4.6 ppm stability compared to 100 ppm for traditional Ethernet. So the concept here is that synchronous Ethernet is an extension of Ethernet that allows clocking and synchronization to be locked and transported across a network. The ITU-T has put in place standards to specify the deployment and performance of synchronous Ethernet. G8261, 8262, and 8264 are the relevant standards associated and related with synchronous Ethernet. Shown here in this diagram are those standards. There are a number of standards in the ITU-T. 8261, 8262, and 8264 specify the network requirements, then the requirements of each clock within that network, and then the deployment model for SyncE. And fundamentally what that gives us is the standards give us a formula or a guideline to deploy a synchronous Ethernet network to transport sync across a network from a single source. These recommendations also specify testing and performance methodologies. So these testing methodologies include tests for wander, jitter, as well as ESMC, which is a management message type. All of these tests and requirements and performance limits are specified in these ITU-T standards, once again giving an operator a set of guidelines to be able to deploy synchronous Ethernet in a network. There's more information available at the Calnix website, including a white paper and a technical brief on jitter and wander. Just to summarize the video again, the technology of SyncE is used to lock synchronization across an Ethernet network and to transport synchronization across that network. ITU-T recommendations 8261, 62, and 64 specify the models, the clocks, and the deployment of these technologies. And within these standards is also the test methodologies. Testing synchronous Ethernet is covered in the next CalNext video, How to Test SyncE. Thank you very much for your attention. There is more information available at calnextsol.com, including the testing details for synchronous Ethernet.